Hello everyone, thank you for coming. In this session I will be talking about dbExpress connectivity to SQLite. SQLite is a popular embedded database and is one of the most widely deployed database engines out there. First of all, my name is Blas. I'm an R&D engineer for Embarcadero and I started with Borland in 2002. What will I be talking about today? I'll be talking about the SQLite driver and metadata, discussing some features of SQLite that I found interesting, and demonstrate building DBX applications that target SQLite. In RAD Studio XE3, we provided a dbEx4 driver for SQLite. It is written entirely in Delphi, so you can link it directly into your application with no need for an external DLL. The source code is provided. We support its use in both Delphi and C++ applications that target Windows 32-bit, Windows 64-bit, and OS X. It can be used in the same manner as other dbX drivers, so it should be pretty straightforward to build an application to target SQLite, especially if you have built a dbX application before. The key driver unit is data.dbx SQLite.pass. As you can see, it is a dbX4 driver, as it is made up of classes that descend from the base classes in data.dbx common. It contains a tdbx driver, tdbx connection, tdbx command, tdbx row, tdbx reader, and tdbx transaction descendants. In order to design and deploy your dbX SQLite application, you will need the SQLite client. For Win32, this is available from the SQLite website at the URL that I have provided on this slide. For OS X, the client library will already be located in your user lib directory, so it should not require any action on your part. SQLite does not provide a precompiled Windows 64-bit client that I am aware of. However, they do provide the source so that you can compile the client yourself. Instructions on doing so are beyond the scope of this presentation. However, you can easily find out how to do it by searching sites such as Stack Overflow and tailor the compilation to your needs. Before I go too much further, I'll show you how easy it is to create a simple SQLite application from scratch. First, I'll create a new FireMonkey application. And I'll drop a T-SQL connection out of the forum. Choose the SQLite driver. And choose a connection that I have pre-configured. Now I'll invoke the Live Bindings Designer. Choose to link a grid up. And I'll hook it up to a country table which has a few records and is similar to the country table in Interbase. And there you have live data at design time. I'll run the application, and there it is. Now I'll hook up a navigator and show some basic editing. Run the application. post the record. And there it is. Data has been changed. There are a couple of connection properties that are unique to SQLite connections. The first property that I'll talk about is the column metadata supported property. This property allows you to control whether certain metadata APIs will get called by the driver. The SQLite client can be built with or without support for column metadata. If your client has been built without support for it, you will want to set this property to false. On Windows, by default, we set this property to true because the precompiled binary that you can download from their site supports it. On OS X, we default to false because the library provided in user-lib does not support column metadata. Since you can recompile the SQLite library yourself, we have chosen to provide this as an option. Another connection property that we have provided is the fail if missing property. This property determines whether an exception will be raised if the database you have specified is not found. By default, an exception will be raised. However, by setting the property to false, a new database will be created for you if the target database is not found. I've created a sample application to demonstrate this behavior. I've hooked up a SQL connection to a new SQLite database that doesn't currently exist. It's located in SQL and CodeRage. I called it test.db. Fail if missing is true by default. In the button click event, I just open the connection. So if I run the application with those settings, as you can see, you get a unable to open database file error. However, if I change fail if missing to false, this does not occur. And if I take a look at my CodeRage/testDB, it's now created. These are the data types that SQLite supports. There's SQLite integer, SQLite float, SQLite blob, SQLite text, and SQLite null. SQLite null will be there when there are no records in the table. Here are mappings for those data types. We map SQLite integer to the N64 type. We map the SQLite float to the double type. We map a blob to a blob binary. We map SQLite text and SQLite null to blob wide memo. And the reason we do that for SQLite text is that SQLite ignores any precision that you put on your varchar field. So if you declared a varchar 10, it would still let you store a string 100 characters in length. It completely ignores that. So we're using a wide memo instead. The metadata support in SQLite is fairly limited. There are some APIs to get column information, but not much beyond that. There is also a SQLite master table that contains information on table and index names. This table also contains the original string used to create the table or the index. One interesting side note on the metadata is the behavior when a table contains no rows. The metadata APIs return a type of SQLite null until a row has been inserted. The usefulness of the metadata can be further compromised by using dynamic typing, which I will discuss on the next slide. Next, I will cover some interesting features that I ran across while working on the driver. First, as I mentioned before, SQLite supports dynamic typing. This means that it does not enforce data type constraints. You're able to insert strings into integer columns, for example. I consider this more of a curiosity, as I don't think it's necessarily a good idea to use this feature. One thing that I noticed when experimenting with dynamic typing is that if you attempt to insert a string into an integer field for the first row that you insert into a table, the metadata for the column will return a result that you may not expect thereafter. It appears that the first row that is inserted impacts the type affinity in some way. I've created a small demo to demonstrate the dynamic typing behavior. I just have a SQL connection and a button click event which creates two tables. Each table contains an integer field. In the first table, we'll insert an integer as we normally would. For the second table, I've chosen to insert a string just to demonstrate the differences in the behavior. So run the application, click the button. So now the tables are created, data has been inserted. So now I have these two queries. The first one is a select star from the first table, which had a integer value inserted into it. If I open the fields editor and I add all fields, the end field is of type T large end field. That's what the metadata told me, so it sets it up appropriately. However, for the second query, doing a select star from the second table, which had a string inserted into the field. When you add all fields, field comes back as T-wide memo field. So inserting data that was different from what we had declared had an impact on the metadata. SQLite also supports an in-memory database that only persists for the life of your application. It is not written to disk. You can leverage this feature by not specifying a database name. When you open the connection, you will be able to use the database normally. It will just go away when your application terminates. I'll quickly demo this feature. First, I'll do VCL application this time. Just drop a T-SQL connection onto the form. Set just the driver name. Don't specify a connection name. Open the connection. And I'll add another button click event to just create some data. I will display the data. Into a DB edit. That's an okay error because we haven't created the table yet. I'll run the application. And there's the data. And we have no database persisted on disk. I don't know if locking is considered interesting, but I thought that I would cover it anyway. SQLite supports many simultaneous readers, but no one can write while others are reading. SQLite only allows one writer at a time. That's a simple overview of their locking. You can go through their documentation for a more detailed explanation. I will now demonstrate locking. So I've created a sample application which has a query that just selects data from one of the dynamic typing test tables that we created earlier. And in one button-click event, it opens the query, and the other button-click event, it inserts data into that same table. Now you'll see when I run it that this will work because it does not lock it within a process. What it does is it locks it so that a second process cannot come along and modify the table while process A is reading. So I will launch the second instance, and I will attempt to insert data. And as you can see, you get a database is locked error. So just something to be aware of. This could be an issue for you if at design time you activate a query and then you run the application from the IDE and attempt to insert data. You may hit this database is locked error because the IDE is one process which has opened the table for reading, and the application that you're running is attempting to insert data into that table, and it's a separate process. So it's just something to watch out for. I can quickly show this. So I activate my query here at design time. I run my application, which is a separate process. Attempt to insert data. Database is locked. So there you have it. We also have support in the Data Explorer for SQLite. So let's kill this stuff. This is the connection that we created earlier. As you can see, there's all the tables that we created. So you can get a list of tables. You could create a new table. I won't do that right now, but you could set something up. You can retrieve data from the table. And you can see the metadata of the table. It also supports drag drop. So if I wanted to drop a connection, just drag drop from the Data Explorer. If I wanted the table, drag drop from the Data Explorer. You got your T-SQL data set hooked up. Pretty standard stuff, but SQLite supports all that. That covers everything I wanted to talk about today. Thank you for coming, and enjoy the rest of the CodeRage sessions. Please submit any questions you have, and I'll do my best to answer them. Thank you.